Good morning, class 9th. In the last class, I had started chapter number 2, Physical Features of India. In that, I had completed the theory of plate tectonic. The theory was given, it was not explained, and some of the important terms were given to you. Okay. Now today we will continue with the same topic, the theory of plate tectonic. And in that plate tectonic theory, what we had seen, a plate tectonic theory, it tells us that this world is made up of seven major and some minor plates. The plates name were given to you. Among them, the Pacific plate is the largest one. Okay, and these plates are either continental plate or the oceanic plates. These plates, they also merge the continental plates with the oceanic plates. Some of the plates were found alone also. It can be only the continental plate or the oceanic plate, but mostly these two plates are found together. Okay, continental plate merged with oceanic plate, because in world the water part is more than 71% water is found. Okay, and therefore the plates number are found more in the water, that is ocean. So the plate tectonic theory is the modern version of one more theory, that is continental drift theory. So to understand the plate tectonic theory, we must know what was continental drift theory. Let us see. So it was a theory that explained how continents shift position on Earth's surface. That means the continents are not stable, they move, they leave their position and they move. Okay. It was first put forward by Abraham Ortelius in 1596. Okay, but this concept was independently and more fully developed by Alfred Wegener. Okay, in 1912, but his theory was rejected. Why? For lack of any motive mechanism. That means Sir Alfred Wegener, he did not have any explanation for how continents could move around the planet. Okay, Arthur Holmes later proposed mantle convection for that mechanism. Arthur Holmes proved why these plates, okay, different plates, they move. So Arthur Holmes, he proposed the mantle convection theory. Okay, so what is convection current in Earth? In the case of the Earth, convection current refers to the motion of molten rock in the mantle as radioactive decay heats up magma, causing it to rise and driving the global scale flow of magma. Okay, most of the Earth beneath us isn't solid. The place where we live on the surface, that is solid. But most of the Earth's interior beneath isn't solid. It is made out of semi-molten rock that cycles and flows through convection current in the mantle, just like the water cycle on the surface of Earth. So this is the structure of the Earth from inside. The first is the crust, you have already studied, and the thickness is about 35 km. If we could think of the Earth as an egg, the crust could be regarded as the shell, the outer part. Okay, and then comes the mantle. 2900 kilometers the depth of this layer, this red color. Okay, and we have two parts, the upper mantle, the lower mantle, and then comes the innermost layer of the Earth, that is the core. Okay, the outer core and the inner core. The densest one, 3500 kilometer. Now, so this is the depth given, the crust. Okay, the upper part of the crust, the lithosphere, we live on the lithosphere. Then upper mantle, in lower mantle, the depth is given here, outer core and the inner core. With the yellow color, the inner core depth is given there. Okay. Magma in the Earth's mantle, it moves in a convection current. the hot core heats the material above it, causing it to rise towards the crust. Okay, after reaching to crust, it cools down. The heat comes from the intense pressure on the rock combined with the energy released from natural radioactive decay of elements. The magma can't continue to rise, so it moves horizontally, okay, and sinks back down. So hot molten magma rises, cools down here, and once again it sinks down. So because of this convection current, the asthenosphere, which is a part of upper mantle, which is liquid in nature, okay, and the upper crust, that is a lithosphere, it floats on asthenosphere. And because of this presence of molten layering mantle, asthenosphere, the crust, which is broken into number of pieces, that is lithospheric plates, they move. So this is the reason why the plates, they move from one place to another place. Just like a ship on the surface of water moves, similarly the crust, it floats on this asthenosphere layer because of this convection current, and therefore the plates, they move. The oceanic plates or the continental plates, they move from place to place. So this is the process of the convection current. As you can see, this is the core, the inner core, okay, and this is the mantle. So the heat which is generated inside the earth, okay, in form of magma, that heat is released, and this comes in the form of convectional current. It cools down here. So hot magma rises, and then, as I told you, it cools down here because of the force of the crust, okay, and then it sinks down. The cold magma, it cools down and sinks down. So this is the convectional current that you can see here, and because of it, the asthenosphere, it moves. Okay, asthenosphere, the lithospheric asthenosphere is the molten form, okay, of the rock. The rocks are molten in form here in the asthenosphere, and lithosphere you can see here. Lithosphere, it floats on asthenosphere, and because of this convection current, it moves. You can see the movement, okay, the two plates, they move, okay, in a different direction.